Hello, and thank you for joining us today. I'm Sarah Larson, Commercial Marketing Manager within Rockwell Automation, and joining me today is Justin. Hi.
I'm Justin Garski, Rockwell Automation's North American OEM segment leader for packaging and converting print and web.
Thank you for joining us today. So we're going to talk about today is industrial robots in manufacturing applications. And to our viewers out there, we'd really like to hear how you're adapting robots in your manufacturing applications that you may not have been before. So Justin, as we're seeing this trend in robots, can you tell me more about what unified robot control is and what it brings to the table?
Sure. So historically, we've talked about robots where you've got the robot controller, right? So it sits on its own thing. It's a box. You communicate to it over a bunch of discrete I/O signals, right? Inputs, outputs. You're wiring stuff up. Maybe you're going to do that over Ethernet IP or another field bus, right? And I can date myself and say device net, right? Or serial if you're that old. But so that was always the thing, right? So you had a program that sat in the robot controller, and it had its own interface methodology and its own language, and you did it that way. And then in our end, in Logix and in the PLC, you'd have another program. And so now you needed somebody who either knew both development tools really well, or you needed two people, and then so training challenges and all the other things that go with it. So as we've kind of moved along this evolution, we call unified robot control, where you're actually doing the robot program and motion control right in studio, right? So there's a handful of instructions and things that we've built out, libraries to go with it to make this easier, right? So it's one tool, one environment, one thing to train on, and it really gives you a lot of horsepower and flexibility without having to learn a new tool, right? So keep it simple, keep it all in one place, and yeah, it's been working out pretty good for us so far.
Excellent, and you just touched on the topic of flexibility. So how does bringing this into the Logix environment, and you said Studio 5000 environment, help our manufacturers be more flexible?
Yeah, so when I think about robotics, I often pair it with our independent cart technology and kind of this mechatronic story, but really when you look at kind of the history of machinery, originally we had line shafts, right? So you had to grind cams and it actuated mechanics, and we did this thing, and everything had to run in lockstep, right? And you look at some of the legacy automotive lines, spark plugs, all these things, it was very rigid, right? It did one thing and one thing only, but it did really well. Turns out we as consumers now want more than one product delivered, more than one size or shape or color. So when we get these things set up, instead of it being mechanical changes, right, where again to adjust those cams you'd go in there, you loosen them up, and it was very special, right? You needed to know what you were doing. Now it's a programmatic change. And if the software from a machine builder standpoint is set up correctly, now it's not even really a program change, it's a configuration change, and then that program kind of adapts the machine, right? So think about just rotating a box 90 degrees. We can pick it up, we can move it around, but we don't have to go just 0 or 90. We can stop anywhere along that angle. So it's a configuration, makes it way simpler. But those two technologies work hand in hand. You think about varying box sizes, different product counts, locations, all of it. So it's where it's all going. It makes it easier to maintain too. It's awesome, yeah.
That sounds very exciting. And with us today to talk about another exciting technology is Curtis. Hi, Curtis.
Hi. So Curtis Beaumont. I'm a mechatronics solution consultant based out of the Twin Cities, Minneapolis, St. Paul.
Excellent. So thank you for joining us. So we've been hearing on today's show about Emulate 3D, a simulation and emulation software. Can you tell me a little bit more about what it is and what it can do?
Sure. First to just dispel any misthoughts, it's not a CAD/CAM program like SolidWorks or Inventor, etc. It does interface with those programs, and basically what it does, you mentioned emulate and simulate. There's two different terms there. Simulate would be like a video of a machine running, right? There's no interface to that machine. Emulation is where we're interfacing to that machine. So you're taking your CAD/CAM program, you're bringing it in, you're applying joints and different things, and actually applying real, either virtual axes or real axes to that, and controlling it through the use of a controls interface like a PLC or PAC. So it's much different than just your CAD CAM software. It actually gives the controls engineer an opportunity to test things out without actually building anything, without cutting any metal, without installing anything, without breaking anything, which is a lot more important.
Which is very exciting.
Yeah.
So how do we take this software and apply it with the trend of robots in industrial applications?
Yeah, we've seen this in competitive applications, right, with our robot competitors, where they have their robot catalogs and they can drop things in, they can test things out, test pick and place applications. But it's generally pretty limited with, like I said, with the competitive vendor applications. With this, that's just one of thousands of components that you can pull in. So whether it's a robot that you want to pull in, or you can pull in a conveyor, or you pull in an eye-track or a Magnum light, or whatever machine that you want to pull in that you've designed yourself, you can interface all of those things together, create a line, create a whole packaging facility, or what have you. It's much broader than what traditionally our competitors have offered. So one application example is we have a machine on the floor that we've developed, and this fine gentleman actually had it in his mind back in May that we wanted to bring this to the show floor. And so from May until now, that's an incredibly short length of time that we all know. We used Emulate 3D. Meaning the team, used Emulate 3D to take the SolidWorks model that our robotics vendor that we were partnering with built, and then we actually brought that to life, right? We attached virtual axes, which includes a Delta robot, a Scara robot, and an eye-track, picking and placing golf balls. And we were able to test that, and with only 2 weeks of actually power on the real machine, we were able to get this thing running, tested, and debugged. And so it's out on the floor here live. So it's very exciting.
Which
yeah,
is
a lot
perfect.
of fun.
Well,
Yep.
thank you both so much. And as Curtis says, we have here on our show floor at Automation Fair our dual robot demo showcasing flexible manufacturing, our Emulate 3D software, and how we're helping our manufacturers be more flexible. So again, thank you for joining us today.